So whenever you are going to arrest the carriers from flowing across the junction, that is called as depletion mode. Whenever whatever voltage you are going to provide to the gate, it is going to increase the number of carriers. That is going to be called as enhancement mode. Okay, so the whatever, if you are going to give a VGS positive voltage, then accordingly you will have enhancement mode of operation. If you have a negative VGS or reverse biased voltage which you are going to provide to the gate terminal, you are going to have depletion mode. So depletion mode means the charge carriers count will be reduced. In enhancement mode, the charge carriers count will be increased. More charge carriers, more current, and more amplification will take place. So the moment you say MOSFET, the people what comes to your mind is conductivity modulation. So I'm going to vary the conductivity of the channel by the applied voltage. Simple terms. Remember what is MOSFET? I'm going to achieve conductivity modulation in MOSFET. So gate is, gate is an insulating layer and it is one plate of capacitor. So metal oxide semiconductor. So up one plate you have metal oxide. Below that you have a dielectric. Below that you have a semiconductor. Okay, dielectric is going to be SiO2, metal oxide semiconductor. So metal is going to be one plate of capacitor. Below that you have a dielectric SiO2. Below that you have a semiconductor. That's why the name metal oxide semiconductor field effect transistor. You don't apply any voltage to gate, the transistor does not connect because the gate and there is no energy for the charge carriers to go from source to drain, giving rise to drain current. When the sufficient amount of voltage is applied to gate, opposite polarity is induced and the conductivity is enhanced. Okay, and this type is called enhancement mode. As I said, if the more number of charge carriers are produced, it is enhancement, and less number means it is going to be depletion. All these are basics. And now we are going to go slowly into what is long channel approximation. We are going to see what is long channel approximation in MOSFET. So the power gain of MOSFET is very, very large. So at you can say at gate, virtually you provide no power because gate current is zero. So input power is almost zero, but output power is very large. Okay, it provides a very high gain. In all devices, whatever you consider, we assume to be channel to be a very long. Channel length is going to be very large. So whenever you are going to see the performance of device, we will always compare it that with the channel length, whether it is a long channel MOSFET or short channel MOSFET. So we are going to see what is long channel MOSFET and what are its properties and what is small channel or short channel MOSFET. So basic N-channel MOSFET, I'm going to consider N-channel MOSFET because I told you electrons have a larger mobility when compared to